Hello and welcome. My name is Albert Labi, and today we are going to dive into the brain of the computer, a topic that dictates how every device in our modern lives functions. Our focus today is on the Central Processing Unit, or CPU. Over the next few minutes, we will demystify what the CPU is, explore the difference between older technology and modern multi-core processors, and see where these powerful little chips live in our everyday world. What is a CPU? It is the central processing unit, but most of us just call it the processor. Think of it simply as the part of the computer that manages all the work with data. To give a clear definition, I like to use this analogy. If the computer were a restaurant, the CPU is the head chef. The chef is responsible for taking all the orders, managing the cooking process, and ensuring every dish comes out perfectly. This leads to why everyone calls it the brain of the computer. Just like your brain manages your body, the CPU is the master controller. It does four essential things. 1. It controls all operations, meaning it decides when things happen. 2. It executes instructions, meaning it follows your commands. 3. It performs calculations, meaning it handles the maths behind every photo you edit or game you play. And 4. It makes decisions and coordinates components, meaning it makes sure the screen, the keyboard, and hard drive all talk to each other correctly. Physical appearance of the CPU. Below is an image of the CPU on the motherboard. What do CPUs actually look like? They are small flat chips that can fit in the palm of your hand. If you flip one over, you will see many tiny connecting pins. These pins allow the chip to plug directly into a socket on the computer's motherboard. The size of a CPU depends on the device it is built for. In a desktop computer, they are about 4 to 5 centimeters square. Laptop CPUs are slightly smaller to save space, while the processors in your smartphone or tablets are tiny, often about half the size of a postage stamp. As for their location, the CPU is always installed in a specific socket on the motherboard. Because these chips get very hot while working, a cooling system is mounted directly on top to keep the temperature safe. Now, let's look at the different types and sizes of CPUs. Desktop computer CPUs are generally the largest and most powerful. They have higher clock speed and more cores, and because they generate a lot of heat, they require robust cooling systems. Common examples you might hear of are the Intel Core i9 and the AMD Ryzen 9. Laptop CPUs are a medium size. They are designed to balance performance with power consumption. A key difference is that they generate less heat than their desktop counterparts. You can identify these with the names like the Intel Core i7 Mobile or the AMD Ryzen 7 Mobile. Finally, smartphones and tablets CPUs are very small, about half the size of a postage stamp. Their main focus is lower power consumption as they are specifically optimized for battery life. Examples include the Apple A series chips and the Qualcomm Snapdragon processors. You might be surprised to find that CPUs are in almost every electronic device we use daily. First, we have smartphones. They rely on a CPU to run your apps, make calls, and process all your data. Washing machines also use them to control things like wash cycles, water temperature, and timing. In the living room, smart TVs use processors to stream content and manage your settings, while gaming consoles need powerful CPUs to run high-end graphics and online features. Even cars have them now to manage everything from the engine and navigation to the entertainment system. On a smaller scale, smartwatches use CPUs to track your fitness and show notifications, and digital cameras use them to process images and control autofocus. Even simple kitchen appliances like microwave oven have a small CPU to manage cooking times and power levels. In short, if a device has smart features or a digital display, it likely has a CPU inside. Now let's look at a key specification: clock speed. Simply put, clock speed is the rate at which a CPU carries out instructions. We measure this in gigahertz, or GHz for short. To give you an idea of what that actually means, 1 gigahertz represents 1 billion cycles every second. So a processor running at 3.5 gigahertz is performing a staggering 3.5 billion cycles per second. Clock speed has a direct impact on performance. Generally, a higher clock speed means the CPU can execute more instructions in that same second, leading to a faster processing and better overall performance. You will typically see these speeds across different categories of devices. Budget processors usually run around 2.0 GHz. Mid-range processors step up to about 3.2 GHz. High-end processors like the latest flagship models announced at the CES 2026 have a base speed of about 4.5 GHz but can boost up to 5.6 GHz or higher when you need that extra power for demanding tasks. Now let's talk about CPU cores. You can think of cores as individual brains within the processor. A CPU with more cores can handle more tasks at the same time because each core works as its own independent processing unit. The number of cores varies widely depending on your needs. Single-core processors are only found in very old computers today. Dual-core and quad-core chips are common in basic budget devices. Hexa-core 6 cores and octa-core 8 cores have become the standard for modern gaming and smooth multitasking. For professional work, we now see high-end processors with 16, 24, or even 96 cores for extreme performance. Having multiple cores is a huge advantage for multitasking. It allows you to run several programs simultaneously, like having a video call while editing a document and running a virus scan in the background without your computer slowing down. This is especially important for professional work like video editing, high-end gaming, and 3D rendering, where the software is designed to use many brains at once to get the job done faster. Next, let's look at cache memory. Think of this as CPU's short-term memory. It is a small amount of extremely fast storage located directly on the chip to hold data that the processor uses over and over again. Cache is vital because it is much faster than your main RAM, sometimes up to 100 times faster. By keeping important data right next to the processor, it reduces the time the CPU spends waiting, which significantly boosts your computer speed. CPUs use 3 different levels of cache. L1 cache is the fastest but smallest, usually a few kilobytes per core. L2 cache is slightly larger and acts as a middle ground for speed. L3 cache is the largest. It is shared across all cores and can range from 4 megabytes to over 64 megabytes on high-end chips. The way it works is simple. Very, very simple. Whenever the CPU needs data, it checks the L1 cache first. If it finds it there, we call it a cache hit. There, it can work instantly. If the data isn't there, we call it a cache miss. The CPU has to look in the slower L2, L3, or finally the much slower RAM. The more cache you have, the faster your computer feels during complex tasks. Now, to wrap things up, let's look at why the CPU is often called the most important part of any device. It plays the central role in everything your computer does. It executes every instruction from your programs, performs all the necessary calculations, and controls every operation. It also acts as a coordinator, making sure all your hardware components work together to turn raw data into useful information. Because it does so much, the CPU is the main factor in your computer's performance. A faster clock speed means a faster computer. More cores allows for better multitasking, and a larger cache provides quicker access to your data. A great way to think about this is with a real-life analogy. The CPU is like the human brain. Just as your brain receives information from your senses, processes it, and then sends commands to your muscles, the CPU receives input, processes it, and sends instructions to the rest of the computer. Without the brain, the body couldn't function, and without the CPU, the computer simply could not think. To summarize what we have covered today, here are the key takeaways. First, remember that the CPU stands for Central Processing Unit. It is truly the brain of the computer. As we've seen, it isn't just found in PCs. It is in almost every modern device we use. Physically, it is a small flat chip with pins on the bottom, and its size changes depending on whether it's in a giant desktop or a tiny smartphone. When comparing CPUs, keep these 3 key specifications in mind. 1. Clock speed, measured in gigahertz, which tells you how fast it processes instructions. 2. Number of cores, which determines how many tasks it can handle at the same time. 3. Cache memory, which dictates how quickly it can grab the data it uses most often. In short, the CPU is essential. It is the heart of all computing tasks, and without it, our devices simply could not function. Thank you for listening.